A glass container, so maybe one like this, has a volume of 34.534 milliliters. A lead sphere with a radius of 0.715 inches has been placed inside of the glass container. How much water must be added to exactly fill the container with the lead sphere sitting at the bottom? So basically the sphere is a space that I need to subtract out of the total space of this container so that I can find out, well, how much water is going to fill the entire container. We have to give our answer in the correct number of significant figures. So we've identified that the total volume of the container is 34.534 milliliters, and that is of my container. And I need to subtract out the volume of the sphere. Keep in mind that milliliters is the same thing as centimeters cubed. So I would like to go ahead and solve for the volume of the sphere, which they tell us the equation is volume equals 4 over 3 pi r cubed. And if we have the unit of the radius in centimeters, then we'll end up with our answer in centimeters cubed, which would then match the unit on our container. So let's go ahead and solve for the volume of our sphere. We'll have 4 over 3 pi times, and I'm going to need to go ahead and convert this inches to centimeters. So I'll do that up here, times, draw a line, 1 inch is equal to 2.54 centimeters. 1.8161, and that is centimeters. Now we'll put the radius in the equation, 1.8161 centimeters, and that value will get cubed. 4 divided by 3 times pi times 1.8161 cubed. We get a value of 25.0904173 cubic centimeters. Now I'm going to go ahead and round this off based on multiplication and division, because up here I'm going to be performing subtraction, which is a completely different rule for rounding. So I started out with 3 significant figures here, which means I can only have 3 when I round this off. So the volume of the sphere will be 25.1 centimeters cubed, and that'll be the value that we'll place up here. So now I can subtract the container and the sphere in order to find out the volume of the container without the sphere. We get 9.434 centimeters cubed. However, this is an addition-subtraction problem, and so we're going to have to round based on the number of decimal places that we've been provided. And so if we line up these two values, we can see here that the cutoff is going to be at the tenths place, because that's as far as this number goes. And so this 4 is going to be rounded based on this 3, which is going to give me a final answer of 9.4 centimeters cubed, which is letter E.